In this video, we'll be looking at differentiation. Differentiation is a branch of calculus which was actually developed by Isaac Newton. Calculus is broken down into two broad parts: differentiation and integration. So in this video, we'll actually be looking at differentiation using the general formula. Now, every curve is governed by an equation. Every curve, every graph you plot has an equation that governs that graph. In most cases, at the end of the day, after you plot your graph, you'll be asked to find the slope. If it's a straight line, for a straight line, the slope is fixed, is the same throughout. At any point for a straight line graph, if this is your straight line graph, anywhere you take the slope, no matter where you pick the slope will be the same throughout. But when it comes to a curve, the slope varies. The slope you get depends on where you're taking it from. The slope at this point is going to be different from the slope at this point. It's going to be different from the slope at this point. But since every curve has an equation, you can actually find a function. Every graph has a function that governs it. So you can actually find a function for the slope, which is called the gradient function. In differentiation, we use a symbol dy dx, where we have dee, dy dx. The y dx actually measures the rate of change. It measures how y is changing compared to x. So the y dx represents your gradient or slope for any function. Okay. The y dx is called the derivative of y with respect to x, or the differential coefficient of y with respect to x. There are various methods of finding the y dx. That is the gradient function. When you are asked to find the y dx, all they are asking you to find is to find the gradient function. There are various ways, but in this video we will be looking at how to get the gradient function using the general formula. For instance, if y is equals to ax raised power n, if a function is governed by this equation where y is equals to a x raised power n. Okay, now what's the meaning of this? You have y is dependent on x. Y is the dependent variable, x is the independent variable. This a here stands for a constant. A constant is just a pure number like 1, 2, 5, 6, 8, 100. The a here stands for a constant. The n here stands for a number to which the x is raised. For instance, y equals to 5x raised to power 6. This expression here is similar to this one. This function here we've just written is similar to this one. This is the general form. This is a specific function. This is a general form of our function. Where in this case now, our a is 5. Our a is 5. Our x is x. Our n is 6. Here, x was raised to power n. Here, x is raised to power 6. Your y is your y. So, if you are given this general function and you are asked to find the gradient function. You are asked to find the y, the x. How are you going to do that? For a general function, y is equals to a x raised to power n. The y, the x is equals to n a x n minus 1. We know that NA actually means n times a. Now n minus 1 means that the value of x decreases by 1 from the initial value. So if n originally was 6, by the time you differentiate, it's going to be 6 minus 1, which is 5. Now, what is happening in the y, the x, when you are differentiating is that the power here comes down and multiplies the a, which is the constant. So n times a gives you na. Then the power decreases by 1. So we are going to take an example right now. So in example 1, if y is equals to 5x raised to power 6, find the y, the x, or find the gradient function. So this is our general function here. This is the formula for find the y, the x when you have this. So we are going to compare these two functions, the general form and the question we have at hand. Looking at both of them, we discover that our a is equals to 5. Here your a here is 5. Your n is 6. So applying the formula where the y, the x is equals to n times a x n minus 1, based on if y is equals to 5x raised to power 6, your dy dx is going to be equals to the 6 here, the power will come down and multiply the 5. So we're going to have 6 times 5 x. Then here n decreases by 1. So we're going to have 6 minus 1. So at the end of the day, 6 times 5 is what? 6 times 5 is 30. Then 6 minus 1 is what? 6 minus 1 is 5. So your dy dx is equals to 30x raised to power 5. Your dy dx is equals to 30x raised to power 5. I go over it again. We're given the function y is equals to 5x raised to power 6. We're asked to find the y, the x, or find the gradient function. So this is the general form of the function. This is the formula for find the y, the x. So applying the formula, our n is 6. Our n is 6. Our a is 5. Our a is the constant, is 5. Our n is 6. So we're actually going to use, based on this formula, we're 6 up here, the power will come down and multiply 5, the constant, which was what we did here. 6 comes and multiplies 5. Then the 6 here is going to decrease by 1. So that's what we have here, 6 minus 1. So at the end of the day, 6 times 5 is 30 and 6 minus 1 is 5. So that is how we got the answer that the y, the x, that is our gradient function, is equals to 30x raised to power 5. There is nothing difficult about using the general formula to find your gradient function or find the y, the x. So we're going to take another example right now. In example 2, the question is, if y is equals to 20x raised to power 4, find the gradient function. The gradient function is the same thing as finding the y, the x. So we'll still apply the formula that if y is equals to a x raised to power n, that the y, the x, the gradient function, is equals to n times a x n minus 1. Now you might ask that why am I calling n times a? Na actually means n times a. That is the meaning of Na. Na means n times a. So to find the gradient function for this function here, we write that the x is equals to, we are going to apply this formula, n times a. Our n, in this case, our n is equals to 4, while our a is equals to 20. Our n is 4, our a is 20. So apply this formula, we're going to have n times a. N is 4, a is 20, so that will be 4 times 20 x raised to power, then n minus 1. N is 4, so that is going to be 4 minus 1. So we have 4 minus 1 here. 4 times 20 is 80 x. 4 minus 1 is what? 3. 4. So our dx is equals to 80x raised to power 3. Our dx is equals to what? 80x raised to power 3. So we're going to look at another example right now. So in example 3, we're asked to find the dx if y is equals to x raised to power 3. Now if you compare this and this, you might say that you have n equals to 3, that your n is equals to 3. Then there is no a doesn't exist, but there is an a, because there is an invisible one here. Y equals to x raised to power 3 is the same thing as y equals to 1x raised to power 3. Now there is a 1 here, but because it is 1, it is expected that you should know that there is a 1 there, so it is not written. So whenever there is nothing written here, just know that the number there is 1. So you are going to use 1. So applying our formula dx. So in this case, our a is equals to 1. So applying the dx, we're going to have that. We're going to have n times a. N is 3, a is 1. So that is going to be 3 times 1 x raised to power 3 minus 1. 3 times 1 is what? 3 times 1 is 3. 3 minus 1 is what? 3 minus 1 is 2. So our dx is equals to 3x raised to power 2. Okay, so remember that whenever you are differentiating and there is no number here, it is assumed that the number here is 1. Okay, we'll move on to the next example. Example 4.
Watch example 4.